What we have here is a contact explosive called nitrogen triiodide. It's a highly unstable substance that detonates when disturbed. Now, you might have heard of nitroglycerin, which is another kind of contact explosive, which goes off when you hit it with a hammer. But this stuff is in a league of its own. Even something like a mosquito landing on it will set it off. Now, the reason this compound is so unstable is all down to how it's put together. Now, it's nitrogen triiodide, so we have a nitrogen atom, and this is a trivalent atom. That means it likes to form 3 bonds with other atoms. So when we bring it together with iodine, the iodines all go on over here, and you can kind of see there's a bit of a problem here, which is that there's not a lot of room for all these iodine atoms. They're much bigger than the nitrogen atom, and so they're all kind of squeezed together and all repelling each other. And this creates something called bond strain or steric strain, which makes the whole molecule less stable than you'd expect it to be, given the components. Now, chemists would say that this results in a low activation energy for the decomposition of this molecule. Everyone else would probably say that it's liable to fall apart. One of the characteristic products of this reaction is this beautiful plume of purple iodine gas. And you can see this again if I chuck this tiny piece of solid iodine onto this hot plate. Now, this iodine is formed along with nitrogen gas as a result of all those triiodide molecules falling to pieces and recombining into a different arrangement. And it's this recombination that releases all of the energy, setting off more triiodide molecules and more in a chain reaction that races through the rest of the substance, decomposing all of the molecules and releasing a huge amount of energy in a tiny fraction of a second. Now, we filmed this same reaction with a high-speed camera so that we can see just how fast it really is. Here at 37,000 frames a second. And again at a whopping 59,000 frames a second. Even at this highest frame rate, we can see that the reaction occurs across just a couple of frames. To go that fast, the shockwave that's propagating through the reaction must be travelling at a couple of miles per second. That translates at around 7,000 miles an hour. And that's actually about what we would expect to happen, because after all, this is the propagation of a disturbance. In other words, it's the movement of a sound wave. As this is an acoustically propagated reaction, we should expect it to proceed at about the speed of sound. But not the speed of sound in air, but the much faster speed of sound in the solid Ni3 crystals. And the speed of sound in solids is generally in that ballpark, a few thousand miles an hour. Finally, when we played back the slow motion footage, there was one other thing that we saw. If you look carefully, you can see, maybe just for a frame or two, that the triiodide flashes as it detonates. And you can see this on both of the videos.